wastewater reclamation facility. It's our newest state-of-the-art 2.5 million gallon per day design wastewater treatment plant. We've just commissioned it in September of 2020. We were able to decommission our old wastewater plant, which was just a little bit down the road, that was a little bit smaller at 1.1 million gallons per day. But it had reached its capacity organically and hydraulically, and it was also in the floodplain down there. So it was very important for us to get it out of that floodplain and increase the capacity so we can keep up with the growth here in New Braunfels. It's 2.5 million gallons per day, but it also incorporates some new technology that we didn't have at the old plant, including odor control. We know that it's right here in the middle of town, so we want to be good neighbors to our fellow residents here. It also has the ability to treat phosphorus that we didn't have the ability to at the last plant. And then it also has some energy efficiency features, including fine bubble diffusion, which really cuts down the amount of electricity that we have to use, and then some good water quality issues. We have a stormwater runoff detention pond, so we can keep all the stormwater here on the plant. So it's really a big improvement for our residents and the citizens of the city. So now let me show you what we got here. So the first step at any wastewater plant is a headworks facility like you see behind me. It includes a bar screen, a grit chamber, and then at this plant we also have odor control. So we really want to get rid of all the inorganics and large solids that can come into a plant through the sanitary sewer system, and that includes rags, disposable wipes that aren't necessarily disposable. You can imagine what gets into sewer. We've got to get rid of that at the beginning of the plant because we can't treat that further on down the line. So we remove those large solids. The inorganic solids are small amounts of grit right here at this spot. And then at this plant, which we're lucky to have, is the odor control system, where we'll actually suck all the air out of that system. We cover everything and pull it through a biofilter and an activated carbon tank so we can remove all the nasty odors that you may get at any other wastewater plant. From here, the next step is going to the aeration basins, and we'll go this way. These tanks hold about 1.5 million gallons of activated sludge. The activated sludge consists of microorganisms which basically eat the pollutants that are in the water. So this is where we get the majority of our phosphorus removal, our BOD, which is an organic loading of the water, total suspended solids, and the ammonia. So this really is the lifeblood of the plant where the majority of the treatment happens. And from here, we're going to go to the clarifiers. So these are the final clarifiers here at the plant. The purpose of these clarifiers is to settle the activated sludge and drop those solids to the bottom of these clarifiers, and then we have a clear layer of water on top that we're going to send to the next process in the plant. The solids that we drop to the bottom we're going to send to the aerobic digesters, while the clear water on top is going to go for further treatment at the traveling bridge filter. All right, from here we're going to go to the aerobic digesters. Well, here we are on top of the aerobic digesters. And the purpose of these digesters is to consume the solids that are still in here, and we have membrane thickeners that will actually thicken the concentration of these solids in here, so we can really reduce the amount of water that goes to the belt press, and that way we can reduce the amount of money we spend when we haul those solids off at the end of the day. Next step for the solids is the belt filter press. So we're standing at the belt filter press, and the purpose of this equipment is really to de-water the solids that are coming out of the aerobic digesters. So the water coming in here are normally about 1% to 2% solid. They go through this belt press, which actually squeezes out the water from the solids, and then at the end of this process it goes to the landfill at about a 17% solid. So it helps reduce the amount of actual solids or weight that we actually have to take to the landfill by getting the water out. So at this point we're done with the solids, but let's follow the water from the clarifiers to the traveling bridge filter. This is really one of the last steps in the process where we're going to filter the water through a large sand filter to get some of those finer solids that are still in the water. And this really helps us meet the low phosphorus limit that we have at this plant. The last step in the process is ultraviolet disinfection. Before we can discharge water back into the Guadalupe River, we have to disinfect the water. We use ultraviolet disinfection light to actually kill the bacteria that's still in the water. We then hit it with a little bit more dissolved oxygen or air so we can make sure that the dissolved oxygen is high enough when it enters the river from here. At this point, compared to what came into the plant, we've reduced 99% of the ammonia, 99% of the organic content, 99% of the total suspended solids. We reduced 75% of the phosphorus. If you were to go out to our effluent line where we're discharging out into the river, you really couldn't tell the difference between the water we're discharging and the Guadalupe River. And that's the last step of the process. Well, thank you so much for joining us. We at New Braunfels Utilities are really proud of the Green Road Water Reclamation Facility, and we really hope it provides a great service for this community for years to come.